this posted maybe at lunch, so it'll be up if you need to go back. And I'm going to talk about something that we're going to do differently this week. Don't let me forget to do that. So weighted averages, that's what we're doing today. And they're doing it with a line, like a line segment, and we're figuring out where to put a point on a line segment using weighted averages. So it's not like using quiz scores or classwork scores, but it's the same concept. But again, because you're not used to doing what we're going to do with a line, it's going to seem really weird, but just it's the same concept. So again, an average, we said if everything is worth the same amount, like everything is weighted evenly, we would call that, then you just take all of the individual numbers, add them up, and divide it by how many total numbers there are. If though our classwork grade, so if that's the classwork grade, if it's not worth as much as our quiz grade, which was 50, we said then that formula doesn't work. Our class average would be below, or our grade in the class would be below 75 because we only got a 50% here, and that 50% is weighted more heavily than the 100 on our classwork. So I was just doing that to catch the recording up. So weighted averages, again, there's a formula we're going to do. I'm going to try to explain it to you, and we'll do some with numbers or with line segments in a minute. Let's say we have a 100%, again, we're going to do the same thing, 100% on our classwork. And we'll still say, I guess, the 50% on quizzes. But now here's how we're going to change it. I'm going to count the quizzes as, how can I do this? I guess I can do it this way. We're going to say that quizzes count as 70% of your final grade, and classwork's only worth 30% of your final grade. So that is exactly what I did last year, as a matter of fact. That's how I broke down my grades. Quizzes were 70%. Now quizzes are 100%. But last year they were 70% and 30%. I want you to, on paper, if you think you know the math behind it, try to figure out what your class average would now be. So I'll give you a hint, it's not 75. Because 75 would mean these things were equal, like they were both worth 50%. But this is going to be weighted more heavily. So it's going to kind of drag your average down toward that number. So if 75 was in the middle, if that's the middle, the average, that's the average based on them being equal. The fact that this is worth more is going to drag down. It's going to weight it down, pull it down more toward this number because it's worth 70%. It's worth a lot more. So on paper, nobody say it out loud. Take a guess. If you think you know the math behind it, you can do the math behind it. I'll give you a second to do that. I'll give you like a minute or two. Actually, give you a minute because most people aren't doing anything. There is a formula. Well, not even a formula. There is a way to, I think, fairly logically come up with it. Seconds. And we at the very least for everyone, you should understand, kind of like when we did line segments and I said, you should know if I put a point on the line, you should be able to explain to me whether or not that point is a viable solution and why it is or it isn't. Kind of the same thing here. If I give you an average, if I say this is the setup for my class, and if I ask you, would an 80% be a possible answer, you should be able to tell me no. That doesn't make any sense at all. Because if this is the average, if they're equal, and I'm counting this as a lot, if this is weighted more heavily, again, the average is going to go down because this is the one that's more weighted more, which means it's going to pull your average down. Whatever is weighted the most, it pulls the average in that direction. Or when we do line segments, it's going to pull the point forward, the point that's weighted more heavily. So like 80% wouldn't make sense because that's actually going more toward the 100%, which isn't worth as much as this. Or this 100% is only worth 30% of your grade. This is worth 70% of your grade. So what do you think? Let's take a couple guesses. Just throw a number out.
65.
All right, so somebody says 65, which again is pulled down toward 50. So I'd say that's not a bad guess. Anybody think higher, lower? Throw another number out. 25. So 25 is pretty low. So I will tell you this. If this is my lowest score, I can't go below that. Because even, think about it, even if this was worth 100, let's say we didn't count classwork at all. Let's say classwork was worth 0, which it is in my class, right? You could get 100% on all your classwork. This would then be worth 100%. So your grade would be whatever your average is there. The lowest you can go is this number. The highest you could go is the other number. It's got to be somewhere in between those two numbers. So that's another thing you need to understand. Your weighted average can't be outside of your highest and lowest score. Still got to be somewhere in between. So with that in mind, change the 25. Can't be below 50, certainly can't be above 100, but got to be somewhere in between those two numbers. 70. So 70 would still be below, so 70 is still a possible answer. 60 might be a possible answer. It's between the 100 and the 50, but it's closer to the 50, which is worth a lot more. It's weighted more heavily.
So since classwork is 30%, since you got 100% on the classwork, you just get 30% of your grade already there. And quizzes are 50%, and they're worth 70. So 50% of 70 is 35. So 35% plus 30 equals 65.
That's absolutely correct. So I'm gonna sort of explain that, but in a little bit different way. But if you get that, now there's more work you'll have to do when we get to the line segments, because they don't give you the percentages. They just give you they just say this point is weighted 3 times more than that. So you're going to have to create percentages yourself, which is a little trickier. I don't think any of the problems just gave you percentages. So if you can do that, then that'll work fine. Or you can use the formula they give when it comes to line segments, which is different, a little different than what you did. But again, if you can figure that out, that's fantastic. So basically what we were doing is we're saying, okay, well, if this is worth 100%, I'm sorry, if this is worth 30%, I can't use that 100 number in my, like I can't just say 100 plus 50, add them together and divide by 2. I need to think to myself, well, out of my total grade, how much of my final grade is made up of this? Well, it's 30% of it. Tells you that right there. So what I do, and again, if you're not following this, you're going to wind up just using the formula. Hopefully you can do enough problems to duplicate it on Monday. I guess we don't need to see weighted averages. I need to say to myself, this is only worth 30% of my grade. I think I told you before in this class, I know I did in algebra, the word of most of the time in math means multiply. So if you don't know that, write that down. The word of, OF, will often mean multiply. So if this is 30% of my grade, I'm going to multiply those two numbers together to give me how much of my grade, how many points I have basically in classwork for my final grade. So I say point, to convert it, to multiply it, although you'll have calculators, so you could actually put in 30%. I think there's a percent. Is there a percent button on it? So you could actually say 30% and then times 100. Is
Second, the, first parentheses.
Yeah, so if everybody's got a calculator, if you don't have one, you'll grab one in a minute. So you'd hit the second function button, that light blue button, which takes you to the text written above the buttons, and the left parentheses have a little percentage sign above it. Take them both out. Got one sitting right here. I know I wear glasses, but I'm not blind, I just can't see up close. So. Give me 10 seconds. One. This is, by the way, if you have a temper, that's how you take care of it. Before it starts, before it gets going, you gotta shut it down. So we'll talk in a minute. I take that 30%. Again, I've already converted it to a decimal. You want to put in 30%, like 30, hit the second function, and then the percentage or the parentheses thing. I just converted it to a decimal. 0.3. My grade was 100. So again, that 100. So this is kind of like 100 points. That 100 points really isn't all going into my final grade. Only 30% of it, which is 0.3, is going into my final grade. So that gives me a total of, you do that on your calculator, you should get 30. So everybody do 30% times 100 or 0.3, whatever, just to make sure you're getting 30. Well, again, 30% times 100 or 30% is the same thing as 0.3. I'm not going to go over how that works because you have calculators. We will have to talk about it when we do line segments, though, because they don't give you percentages. They give you how much something is weighted. So we've got to convert that into a percentage, or you just use their formula. All right, so now that's how many points I get from my classwork toward my final grade. So final grade is going to be made up of my classwork points, and now it's going to be made up of my quiz points. Well, for my quiz points, it's worth a lot more, so it's 70%, so I'm converting that to 0.7. If you don't know how to convert a percentage to a decimal, you need to look that up on your own, or just put in 70% on the calculator. Now, the points that I had from quizzes was 50. So again, I'm just taking that number. I don't need to put it in as percentage because it's representing a total number of points. And that multiplied together gives me 35. So if I now say, okay, well, I got 30 points from my classwork. I got a total of 35 points from my quizzes. That comes out to be the 75 or 65, sorry.
You have it.
And yeah, if you want to know what grade that would be, that'd be a D. So that's the concept. Now, I don't even know if they have any word problems that are like, I'm not having you tear pages out of the book. This is not my favorite lesson. What we're going to do is I'm going to give you a couple of these problems on Friday. We're doing it this week, by the way. Wait, Thursday for you guys. So next class. I'm only going to give you a couple of these problems. So you don't even have to remember this until Monday. If you can just duplicate the formula on Thursday, you'll do fine. It's only going to be one standard this week. But here's what I'm going to allow you to do on Thursday. I'm going to let you do a retake without going through the retake process. So for those, and this is only for the first quiz. So on the points, lines, and planes, and the back of that was line segment, like solving for how long a line segment is. Not partitioning, not midpoints. You can't do that one. So the very first quiz, there were 2 grades. The first grade, like I said, was for the points, lines, and planes. The second grade, the back of that sheet was for figuring out how long a line segment is, depending on what information I gave you. I will let you do one retake and you have to pick which one of those. So for some of you, if you got a passing grade on one of the two standards, it's pretty obvious you're gonna wind up taking the other. You should take the other standard, the other quiz. If you didn't get any passing grade at all, then you gotta pick which one you wanna take. And if you got 2 passing grades, you can still retake it. And if you do better on whatever your lowest grade was, then I'll it up. That way, hopefully, we can get a jump start on the retake grades without you having to go through the whole process. This is not really going to be a regular thing. I wasn't even gonna do it this time, but because this is the last lesson of the chapter, so there's really not a second standard to put in with this. So I figured we'd go ahead and take advantage of that and do a retake in class after we do this. So you will have to take this one first. It's not going to be like all on the same quiz. So you'll do this quiz when you get done. I said, yeah, it looks like you're done. I'll ask you, okay, which one do you want to retake? And I'll give you that to retake. So you need to practice whichever one, look at your grade, whatever your lowest grade is. If they're both low, if they both say retake, just figure out which one you want to study for. And that'll be the one that you'll tell me you want to retake on Thursday. All right, so now what we have to do is we have to take this concept and we have to convert it to line segments. So let's go to my online book. Yeah, I feel like it's not as obvious, like, and I'm not saying grades are obvious, but you can relate to grades. Like you get grades in class. You kind of have used this grading before. You've used weighted averages. A bunch of people raise their hand saying, yeah, I've had classes where it's, 100 or 70% for my tests and quizzes, but 30% for classwork. Or maybe they had 3 grades. Maybe they put in their homework. Sometimes, I think my very first year of teaching, I had homework was 10%, classwork was 30%, and then quizzes was 60%. So there were 3 things in there that were weighted. And your homework grade only counted a little bit because it was only worth 10%. It was weighted very low. Like it really didn't affect it a whole lot. It might raise it a point or 2, but ultimately you had to do well on the classwork and on the quizzes. Yeah, I don't know why. I guess this time's out if I haven't used it. Yeah, and I don't know why things do that. I don't know if I think sometimes it's a security issue that they don't want, like if it's got information that you don't want other people seeing. But I think also, it's also something to do with if they leave it on forever and everybody's got it open, it takes up a lot of bandwidth on their servers or wherever whatever you're accessing. If everybody's accessing it and just leaving it open and they don't shut anybody off, then that's how sites crash, basically. So that's why they really started to shut stuff down if you haven't used it. All right. So what page would we be on? We finished like 38, I think. So maybe around 39. Oh, 40. Nope. There we go. Weighted averages. All right. So let's say, and again, this is probably going to get kind of complex. Let's say we have that. So there you can see the formula is kind of out there. I'll come back and explain what that means, but let's just talk about what it means first of all. If I've weighted, let's get to a problem. Oh, that picture. Let's go to example 1. All right, so here we go. So I'm assuming, yeah, so we have a line segment. And they're telling us in this line segment, point C weighs twice as much as point D. And that in and of itself probably seems pretty weird. Like, how can a point weigh more? Like, what does that mean? What does that mean that the point weighs more?
It'll be close to that. like it'll be closer to that point, like what we were just doing, the 50%, it was closer because it weighed 70.
That's all it means. Don't get hung up on that word weighs. Remember how I said your classwork grade, whichever one was worth more, and whichever one weighed more, it just means it pulls the average, the weighted average, it pulls it toward that number. So if these were worth equal amounts, if C and D were the same, worth the same, where would your point be? Where would you put a point if they were worth equal amounts and you wanted to put a point between them?
Right, but
Yeah, where would it be?
between -1 and
Around -2 to -1.
So if they were worth equal, you're saying between -2 and
Oh.
-1? I'm saying if they were worth equal.
Oh, it would be negative 0.5, basically.
Dimitri, what do you think about that? You think 0? All right. What do you think, Andrew? So I'm just gonna write some numbers up. So we said, somebody said 0. You said 0.5. Is that what I heard somebody say? 0.5. What do you think, Andrew?
I said -0.
Oh, you said -5. All right. What do you think? 0. What do you think, Nesto? 0, another 0. If they were weighted equally, what are we really finding? We're finding the midpoint. If they're equally weighted, what we're saying is it's really a ratio of 1 to 1. That's what equally weighted would be. So if they're not equally weighted, and this is weighed twice as much as point D, what's the ratio that we're really using? So that, by the way, if you wanted to know where that midpoint would be, I'm just going to eyeball it. The formula would be -3 + 2, but it would be 2.5. So it would be the -0.5, because this gives me 2.5 line segments on the left, 2.5 on the right. That's the midpoint. If I know that the length of both segments are the same, or I would say -3 + 2 divided by 2, which also gives me -1/2. So what would our ratio be if C is twice as much as D?
It's 1.
It's 2 to 1. Literally, we multiply D times 2. So I'm just taking exactly what they told me. C weighs twice as much as D, and I'm starting with 1, 1 because I know that's the midpoint. But now I've got to change the weighting, so I just multiply D times 2 because C, oh, why not change that? Because C is twice as much as D, and that gives me my new ratio. Now we're just partitioning, just like we did partitions before. We're partitioning the line using that ratio.
So wait, wouldn't the point now be close to D?
So
It's the ratio
it'd be closer to which point?
D, because it's
Is
2
D
to
the
1.
heavier point? Which
No.
one weighs more?
The C.
C weighs more. So again,
Even
at
though
the
it-
very least in this lesson, what you need to understand is how to find the midpoint, which we've done. And then you need to be able to tell me or explain to me if I give you a point and I say, is that a viable point? You need to be able, so let's say I gave you a point on the line. I say, is this a viable point? Right there. You need to be able to say, well, wait a minute. I know the midpoint would be here. I know C is weighted more, which means it will pull the average. So if that's the average, like if that's the average right here, if it's equally weighted, but then C is weighted more, it's going to pull the average towards C. So you need to be able to explain to me, no, that is not a viable option. It should be, the point should be closer to C because C is weighted more. Even if you can't do all the math and figure it out, that will be kind of like on the last quiz. I had a question very similar to that, and it was about partitioning, but it was the same concept. You need to be able to at least explain that to get some points. And I'm not saying that'll necessarily pass, but if you can do that along with maybe one other problem, then that would certainly be passing. Now, in order to do the rest of it, we're really just partitioning the line. We're just saying, okay, I need the left segment. Oh, but wait, does that make sense? What's wrong with that?
See, twice as much as point D. Wouldn't the ratio be the other way around?
It is, because if I use this ratio and I partition it, right? I forgot to mention this. That's gonna make the left segment longer, right, than the right segment. And we know that's not the case. We just said the point should be closer to C. So we did the right math in that we multiplied by 2,
That's what,
but you have to remember the ratio is actually flipped. You just have to understand that the left segment has to be smaller than the right segment. So you are still multiplying by 2, but you're actually multiplying the D by 2, not the C by 2.
that's what, that's it, when it's showing that on the ratio, it's showing that. Like 2,
Right.
and you show that.
Because we're counting this number here really 2 times more than we're counting the 2.
It's,
So yeah, so I guess we can partition it real quick. If it's third, does it come out nice and even? 1, 2, 3, 4. Doesn't come out nice and even, so we got to do the long version. I'm going to very quickly go through the steps for doing the partitioning. So again, it doesn't have 6 segments or 3 segments, so I can't just eyeball it and figure it out. I've got to change my ratio into a fraction. How do I do that? Were you here for this?
it's, add the total.
Yeah, so I take the first number and I put it over the sum of those. So first step gives me a fraction of 1/3. If you don't remember this, I'm going through it fast. This was the partitioning that we did last week, and that you'll see probably again if you're doing a retake, which I haven't graded them, but I have a feeling definitely some people are going to be doing retakes. So now I need to figure out the length of the line. How do I figure out the length of the line from C to D? Length is just what we said. Christian. Whoever popped their head up. How do I figure out the length? What's length, we said? And I could just count. If it's a number line, I can just count, but the other way we figure out length. If it's on a number line, this doesn't work on a graph. Yeah, we said length is just subtraction. I would just say 2 subtract -3, which changes into a positive number. And that gives me 5. Or again, I could have just counted 1, 2, 3, 4, 5. What do I do as my third step? We say the third step was, once I've done step 1 and 2, I've figured out the fraction, I've figured out the length of the line. Multiply them together, right? Now we just do some math with them. So I say 1/3. Again, you have a calculator, so that gives me 5/3, or it'd be 1.666666 forever. And now, and what does that represent? What does that 5/3 represent? Where did I leave off? Dizia, what's that 5/3 represent that I would figure out in step 3? So step 1, step 2, step 3 was multiply them together. What do we say that represents? Step 3. It's not where the point goes, we said. We said that doesn't make sense because what would that be? 1.6666 would be way over here, and we know that's not right because we said it needs to be somewhere. Oh, our estimate, by the way, I always like to estimate. So if it's in a ratio of 1 to 2, that's the midpoint. Probably going to be somewhere in there. Getting a little cluttered, but we'll do that. So what did we say that represents? That 5/3. Just calculated something out. Say it again. Yeah, it's the length of the first segment, or the left segment, you could say. It's probably a little more clear to say the left segment. So if the length of the left segment, and I'll write this as a decimal, it's about, so 5/3 is about 1.67. Technically, it's the 6 repeats forever. So if that's the length of the left segment, I need to then add that number back into our starting point. So I need to say -3. So this is step 4 now. -3 plus 1.67 would give me -1.33. So -1.33 would be right there, right in the circle where I estimated. So I feel pretty good about that. So that's how you would do a problem like that if you tried to use what we learned before and you said, well, I know if this is twice as much, I can create a ratio. Again, make sure you don't get the ratio backwards, because I even got it backwards first time when I didn't really think about it. So just make sure your ratio makes sense. If this is weighted more heavily, it's going to pull the point that way, which means this segment has to be shorter than that segment. So that ratio matches up. The left segment is shorter than the right. Now I just use that and I just do the same thing we did for partition. So that's one way you can do it. And we're going to get into some harder problems where you won't be able to even do it that way. You'll have to use the formula, because sometimes there are 3 points and you have to take into account all 3 points. And we can't really do that with partitioning.
Wait,
So then you'd have a whole new formula where there'd be a third thing and a third thing on the bottom.
so we,
Now here's their formula. I'm going to explain to you what all this W1, X1, all that junk means. They're just taking the numbers, and the weight 1 and the weight 2 is going to be the 2 and the 1. So this is weighted 2, this is weighted 1. The X1 and the X2 are the X values, because think about it, this is a horizontal number line, right? So the X-axis is horizontal. So if you forget, and again, if you practice this enough, it'll just be a matter of using the numbers, but this means the first weight, that means the second weight. So the first weight is 2. Second weight for D is just 1. Well, then I'm sorry, the second weight is the number 2. Let's see. Let me get rid of some of this stuff now that we're doing the. Is anybody still writing that down, doing it the partitioning way? All right, let's get rid of all of that because that's getting too. Let's start over with the formula. So if you want to just try to get the formula down for Thursday, the weight 1 is the twice as much part. Because it needs to correspond with the 3. As long as you put the 2 numbers together, it really doesn't matter which one you call weight 1. You just need to make sure that if C is the heavier one, the -3 goes with the 2. You can call it weight. You could call it W2 and X2 if you wanted to. It doesn't really matter. As long as you make sure this -3 is the one that multiplied by 2. Oh, all of this means multiply, by the way. That's W, the first weight, times the first X. That's the second weight times the second X. So remember, that's multiplying in between those. Down here, we're just adding the 2 weights together, 2 plus 1. So W is the weight, X is the value on the number line. And then weight 2 would be just 1 in this case. So I need to make sure I match up the correct weight with the correct X value. Well, if C is the one that weighs twice as much, then that means the X value of 1 is the -3, because that's C. C is twice as much. Well, the X value at C is -3. So you just need to make sure those 2 match up. Again, the weight for D was 1. Well, what's the number? What's the X value for D? Well, it's 2. So X2 is the 0.2. I'm going to color code this a little bit. One. So that's where I got those from. And then the weight came from here. C is twice as much. So that's where I got the C weight is that. And then the D weight It's just one. So now we just plug them into the formula and we do the math. I want you to try to do that. I've given you what all the numbers mean. I'll zoom in. Oh boy, I don't know. I hate. Oh, actually, I might be able to do it. Trying to get it to where it's. Oh, okay, there we go. So you're doing this formula. I've given you what everything equals. I've given you what all your values are. I just want you to solve it on the calculator. So you're just plugging numbers in, making sure you can do it. The hardest part is figuring out. Well, the hardest part is memorizing the formula. You're done, just kind of look back up to me so I know you're done. You're doodling, I can't tell if you're done. And the answer to this will be where the point goes, by the way. You may want to jot that down. It's not like the partitioning where we then had to add it back into the beginning number. This will be where the point goes. It should be the same answer we had for the point.
Sure.
This is the answer. That's where the point goes. So if you need to make a note of that, that's your final answer. Like I said, when we did partitioning and we like multiplied the two things together, we then had to add it back into the original point. We don't do that. Whatever you get in this formula is your final answer. And we would do the same thing in the beginning, kind of estimate where we thought the point should go. Did you have a question, Andrew, or? Well, I'm gonna go ahead and start setting it up over here. You can keep working. So W, coordinate that. And what color am I missing? Red, blue. Oh, okay, I guess I can. Well, I'll just use red and put a red box around it. Color coordinate it. W1. Then we need X1, which was what color? Blue. X1 next to C. We don't use that at all down there. W2, red. Oh wait, I need that down on the bottom. And then last but not least, X2 is what? Green. I think that should be your formula. Yeah. So you should have done something like that. Again, the main reason I'm doing this is because these calculators can get a little tricky when you're doing a more complex equation. You have to know how to put in. So I want to call out answers that we got. What'd you get, Andrew? What's that? All right, you guys should have an answer by now. If you can't, I mean, I've done everything for you. You can't plug into a numbers into a calculator fast enough. I'm going to go around. So I'll come. Again, either you're not doing anything, which is not going to bode well for you on Thursday, or you need to get faster at it. Because there's no reason. I mean, I gave you plenty of time to do it. Then I did it for you and still have people that weren't done. Kiana, what'd you get? All right, again, should not take that long. worry about you if you're really, truly still doing it. You need to be getting tutoring. I have a feeling a lot of you that say you're still doing it really weren't doing it in the first place. So if that's the case, then you need to start working. Really, truly struggling to plug numbers into a formula and get an answer with a calculator, then you need to go to some tutoring. Or you need to be asking questions if you don't know where to plug it in. Not a single person raise their hand. I don't sugarcoat stuff. I'll give it to you like it is. I'm more than happy to help you, but if you're sitting there doing nothing I can do with that. Don't come to me at the end of the quarter when you've got like 4 or 5 retakes still left to do, and there's not a physical way you're gonna have time to get all of them done. Don't beg me to do them without the process. I'll say no. I'm gonna hold you accountable for your decisions. What'd you get, Morgan? And the 6 goes on forever, right? Is that what you got, Lucas? Anybody get anything else other than that? If you did, speak up now. Put 0.67 rounds up. Anybody else? I guarantee you somebody got some help. Thank you for saying that. All right, -1.3. Did anybody get that? Now that somebody was willing to admit it. You need to go over what we're plugging into the calculator and how to do it. Because these calculators work very differently. I'll tell you how I would do it. I wouldn't use the calculator and try to plug it all in at once. I would do each piece separately. I would say, what is 2 times -3? And then I'd figure that out and I'd rewrite the formula. I'd say, well, that's -6. I would then say, what is 1 times 2? Oh, that's 2. And then I would say, well, that is all going to be divided by what is 2 plus 1. That's the way I would do it. Especially if I were pressed for time and I want to make sure I got it right. It doesn't take that much longer with a calculator to do a couple steps instead of trying to plug it all in at once. I'm telling you right now, plugging it all in at once on a calculator, and this math was pretty,